So it turns out this is much easier to show with a flyback transformer. I have an old flyback transformer from a neon thing I forgot I had in the basement, but so my ground is here for the chassis. I've got this thing running. This is, again, it's just essentially a flyback transformer. We've got really nice stream plasma here. I'll turn the lights out, you're really going to see, but I've got a magnet, just a parts catcher, and you can actually see it move around. So I believe what was happening is before I was using high voltage AC, and so as the field was going back and forth, you're actually generating, there's a big electromagnetic field going on as well. So between the 2 points, it was actually sort of creating its own magnetic confinement. It's my theory anyway. Somebody else can chime in if that's right. But with DC, it seems to not be the effect. So with DC, I get this nice arc, and I can deflect it very easily. I was looking online, and I'm using a couple thousand volts here, whereas in the a lot of the demos online, people are in the range of 500 or so volts for the normal CRT, and they've got a plate of phosphor in there, so you can use it 5 to 700 volts, and you've got a much lower voltage. Oh, and it's very easy to deflect that stream. So I think as the voltage gets higher, there must be some sort of magnetic component too. But either way, there's a beautiful streamer going on in there. Looks much better with lights on, and you can see we've maintained an arc at, so you can't see, 25 inches of mercury. So I'm going to increase the vacuum, and then we'll see what's going on. And the X-ray production is still non-existent. So again, not a high enough vacuum, not a high enough voltage DC to really get some good. It looks like I need to be 20 kilovolt plus to really generate some good X-rays, so I'm not really too worried about that with this setup. I'll probably need to open the valve, that would be helpful. There we go. Like I can hear the vacuum pump make a little noise as it actually starts doing work. Got my safety spectacles on. Let's grab my giant channel locks and my magnet. This is my poor thing here. I have been shocked by this flyback. It's not the best feeling in the world, but it won't kill you. Alright, let's get this guy back over. And then, there we go. Alright, now I'm going to take Mr. Magnet and just bring it close to the glass. You can see it moving around with the field. Much easier to see with DC. So I could put those electrodes a little closer together if I wanted to, I suppose. But again, looking at Mr. Geiger counter, we are at no counts. You see a blue light flashing. So again, that EM discharges, it's generating massive amounts of RF craziness whenever it's arcing out like that. So we're at a higher vacuum now, but it's that beautiful glow. Used a knockout plug. Let's see if I drop that lead down in there a little more, if we get some better light show. Alright, let's draw back down. Once we get below 25 inches of mercury here, it's right about there, I'll cut the power back on. We'll just see what this thing looks like. There we go. The streamer looks pretty again. It's moving the whole darn plate in there. I think it's actually less evident. There you go. So, obviously at lower voltages with a nice phosphor screen, much easier. I'm using a permanent magnet, not an electromagnet in this case, and I think it's a little less brilliant this way. So, not as impressive, but you do get some beautiful hue off this thing. So there you have it. If you're wanting to do this and you want to have some sort of deflectable plasma. It's much better to have a DC source. This flyback transformer was just something I forgot I had on the shelf. That'd be funny as I increase the gas in this chamber. You can watch as it slowly blinks out, and it'll probably arc a little. Of course, remember the RF is going to freak out the... Look how it's getting hot when it hits that metal. Anyhow, there you go. Just a basic flyback transformer, and it gets a little bit of arcage going on. So, all right. Hope you enjoyed that.